Here we go again. Unit 4, Day 2. And might I draw your attention to one of my most favorite words in math? Factoring. It's beautiful. It's lovely. It's like one of my favorite words. It's one of the few F words you're allowed to use in class. Fun is another one. Fantastic teacher. Yeah, teacher doesn't have an F, but we'll put it all together in one word. Fractions. Ooh, fractions. Fractions and factoring. That's coming later. That's a lot more fun too. Okay, so believe it or not, factoring is one of my favorite things to do. We're going to be factoring different degree polynomials. So this is a little bit past what you would do in algebra. This is algebra 2 factoring. I only factor by guess and check. I only think that's the only way you should be able to factor. I don't even know if that sentence made sense, but that's the way I think you should factor. If you factor by any other method, you have to go online and figure those things out. I think guess and check is the only way you should be doing it. I think as you progress in mathematics, your brain should develop patterns. You shouldn't have to have rote steps to figure out how to factor. You should have just developed patterns of numbers, and being able to manipulate numbers in your brain, in your head, is very important. So hopefully this will make sense to you. It should be a very short video. We only have 20 questions. That sounds awesome. Only 20 questions. I think we should do more. At any rate, I did have to make a couple of changes. For those who had the original sheet, I did have to make a couple of changes. The first one had a change in it. We changed this plus to a minus. Otherwise, it wasn't quite as exciting. All right, here we go. As you recall, the very first rule of factoring is factor out the GCF. So you look at each term, x cubed, x squared, 6x, negative 6x actually. Do they have something in common? Of course they do. They have an x. So when you factor out one set of whatever that GCF is, don't forget you have to fill all the holes. So in this case, if I take an x away from x cubed, I'm left with x squared. If I take an x away from x squared, I'm left with a plain old x. And if I take away an x from 6, I'm left with 6. But you're not done there. We mathematicians want you to continue to have fun in your quest to be amazing with numbers so you can continue to factor. X and x. Now, I'm not going to go through the basics of factoring. If I ever get around to doing a basic algebra factoring video, I'll maybe get into that. But as far as this goes, what you need, I'll keep reminding you, because this is negative, I mean, you have to have one of these has to be positive and one has to be negative, and they have to add up to, and I'm going to put this 1 in here even though I don't need to. They have to add up to positive 1. Since they have to add up to positive, the larger one has to be positive and the smaller one has to be negative. Question 1, finished. And that looked terrible when I just circled that. Kind of upset me. Okay, here we go. We see that we have a 2 that we can take out because they're all even. Clearly a 2 can be taken out, and also an x. So our GCF in this case is a 2x. Again, I'll put these 2 signs in just so I don't forget to fill all the holes. When I take a 2 and an x away from this, I'm left with x squared. When I take a 2 and an x away from this one, I'm left with 8x. I believe this is a massively changed question. This was an 8, and this was a 98. Those are changed massively. Massive. That sounds like cool. That's a cool word. 48. Again, here we go. Because it's a negative 48, the two numbers, one of them has to be positive, one of them has to be negative. In this case, it's rather simple. Hold on a second. I think I screwed this problem up. Nope. I'm a genius. I did not. Plus 12 minus 4. I don't know what I was thinking of. I was thinking of 64 for some reason. Again, numbers just roll through my head. That's how lame my life is. Numbers just keep rolling. Sometimes they roll and roll me right over it. These multiply to negative 48 and they add up to positive 8. So we're finished. All right, so this will be our first polynomial. It's got 4 terms. So what we'll do with 4 terms is we're going to group these. Group them as the first 2 terms and the second 2 terms. In order to do this, it's probably in your best interest, which it is, to put them in order from least to greatest. As far as degrees goes, notice a 3, a 2, and a 1, and a 0. For most of you in Algebra 2 or Trig, especially in New York State, that's how they're going to come to you. We just expect you to understand some different factoring techniques, and we're not trying to trick you too much. We do enough of that in other areas. We're pretty good at it. We're pretty good at it. Okay, so these two terms, they have an x squared in common. So if I take an x squared out, put a plus, I got to fill those holes. Well, take an x squared away from x cubed, I'm left with x. If I take an x squared away from 2x squared, I'm left with positive 2. Now, this negative has to come down. Those of you that factor by grouping, everything gets factored by grouping. You're probably very familiar with this. Those that use guess and check, this is a little bit strange for us, but no big deal. If I look at 25 and 50, first of all, I'm taking out a negative value. So I got to be really careful with that. The largest number that goes into 25 and 50 is, in fact, 25. In this case, we're going to factor out a negative 25. So I get an x and a 2, but it's actually a positive 2. Because negative 25, when I distribute it to here, times positive 2, gives me my original negative 50. The other thing I want to look for, and I want to make sure that I have, is that these parentheses, this one and this one, match. If they don't match, you either did something wrong or that problem can't be factored in the way you're trying to factor it. And you might have to come to a different way. Now, if I look at these two terms individually, I look at them as one big term with a minus sign in between. I think to myself, well, they both have this as a GCF. This is their greatest common factor. And I'm going to put that out front. That's my first parentheses, x plus 2. Now when I factor that away from both of them, I'm left with x squared minus 25. And some of you are looking at it going, that looks familiar. X squared minus 25, that looks familiar. Oh yeah, that's the difference, subtraction, of two things that are perfect squares, or the difference of perfect squares. And yes, it is. Nothing to do with the x plus 2, we'll leave it. But this is going to factor to x plus 5 and x minus 5. And I'm running out of room, so I'm not going to try to circle it because that's your final answer. You'll see that idea pop up a number of times if you haven't seen that before. As a matter of fact, you'll see it right here on this next problem. I will often get kids that freak out about the fact that this is a 4. Because you're in Algebra 2 now, not algebra. You have to deal with 4th degree polynomials. Take a 2 away from x to the 4th, I'm left with just x to the 4th, minus 16. Well, this is also the difference of perfect squares. X to the 4th is a perfect square because I can rewrite it as x squared times x squared. It's not a big deal. It's just as if it was x squared minus 16, which you guys should be very familiar with. It's just x squared and x squared. In this case, they multiply to 16, in fact, excuse me, negative 16, so it's a positive 4 and a negative 4. Well, as I look at this here, this thing I'm not done with. This is, again, once more, the difference of perfect squares. Not here. You can't do anything with the sum of perfect squares. This cannot be factored. It's finished. Leave it. So it's 2x squared plus 4. And then this is going to be x plus 2, x minus 2. Done. Number 5. Again, I don't freak out about this, that this is an x fourth. Uh-oh, I just saw a mistake. This should have a 2 on it. So freak out because it doesn't have a 2 on it. It should have a 2 on it. You'll see why in a second. X squared and x squared. What multiplies to 45? Well, the easiest way to multiply, here's my guess and check. The easiest way to multiply to 45 is 9 times 5. So minus 9. Oops, this should be an x squared. And minus 5. Now, if I look at it, this is minus 5x squared, and this is minus 9x squared. There's why this has to be 4x squared as well. Oh, some of you are smart enough, you're seeing this. What's it called? I can't hear you. No, talk louder. Can't hear you. Oh. Yeah. Good answer for Tita. It's called the difference of perfect squares. X plus 3. X minus 3. Oh, DeLong whispered in your ear. DeLong, you better stop. You better just stop that stuff. Oh my God, I'm such a comedian. This is not the difference of perfect squares because 5 is not a perfect square. So I'm finished. Done. See ya. Wouldn't want to be ya. Keep going. Are we solving any of these? We're not solving it. Why? Oh, there's the solving. So this is, oh, I said 20 problems. I lied. We have 26 problems. So I'm going to get moving so we can go through these quickly. And I know what you're saying. You're saying to yourself, man, the guy already talks fast enough. How come he's going to move any faster? You can handle it. Pause, rewind, go in slow motion so you can see me moving in slow motion. Should have been an actor. Oh yeah, should have been an actor. X squared is our GCF of the first two items. Notice there's 4 terms. 4 terms means I'm going to group them as the first 2 and the second 2. I hope my parentheses match. If my parentheses do not match, either your teacher is an idiot or you are. Okay, could have been I just made a mistake. Not an idiot. Hopefully I didn't make a mistake. Take out an x squared, I'm left with x minus 7. Copy over that plus sign. I take out a 4, I'm left with x minus 7. Feeling pretty good about this one. Again, we're going to factor out x minus 7 as the GCF. It goes first. My second set is x squared plus 4. Now, you might be inclined to continue to factor that. You cannot. It's the sum of perfect squares. Finished. You'd be thinking to yourself, oh, teacher made that one easy. All right, maybe this one's not so easy. Let's look at these two. Take out a 4x squared. This one's going to get a little funky. Funky Co-Medina. Man, I gotta check that song out. I haven't heard that song in a long time. Yes, I know, I'm lame. X plus 2. That felt better. Factor out a 4x squared. I'm left with x plus 2. Copy over this negative. Look at these two. I can take out a 9. Really, what I'm taking out is a negative 9, so be very careful with your signs. Again, your parentheses have to match. There's the x plus 2. X plus 2 would be my first set of parentheses. I'm factoring that out as a GCF of that term and that term. And I'm left with 4x squared minus 9. Okay. Oh, yeah. That's the difference of perfect squares. It is true. I heard somebody say it. I'm not sure who. Somebody was really talking loud. So, 4 is a perfect square. X squared is a perfect square. Subtraction and 9 is a perfect square. So I'll rewrite this as 2x and 2x plus 3 and minus 3. Done with that problem. Let's see. Looks like I got difference of perfect squares again. Bet you don't believe me. We're going to be doing a lot. This thing right here is going to turn out to be some crazy factoring. And you don't even believe me yet. So we're going to take out a 2x. Now remember what I said. Got to fill the holes. When I take a 2x away from 32x to the 5th, I'm left with 16x to the 4th minus 1. Now, if you stop there, you are not going to fully enjoy the beauty of this question. Or you just won't get it right, one of the two. Beauty. Beauty's this. Bald is beautiful. Everybody knows bald's beautiful. Keep factoring. This is the difference of perfect squares. 16 is a perfect square. X to the 4th is a perfect square. 1 is a perfect square. All of it's perfect square, and we're subtracting. So this is going to be 4x squared minus 1. 4x squared plus 1. Difference of perfect squares. These are called conjugates. They look exactly the same. 1's plus, 1's minus. I'm still not done because this is the difference of perfect squares. So we got to do it one more time. And let's see, 2x times 2x gives me that 4x squared. 1's plus, 1's minus. The only way to multiply to 1 is 1 times 1. That's not exactly true, but for today, we'll count that as the only way to do it. 1/2 times 2 would be 1. We want negative 1. Okay, negative 1/2 times 2. There it is. I told you this is going to be some beautiful stuff. Now, I didn't factor this one because it's the sum of perfect squares. So I took out that seemingly easy problem and turned it into this. Why? Well, because now I can talk about the roots. I've got 0, negative 1/2, positive 1/2. Yeah, this one's going to be positive or negative 1/2 I. We're not there yet. We'll get there. We'll get there. Factoring. Let's see. I can take out an x squared. Now this problem I know gives all kinds of people all kinds of problems. They like freak out about this problem because it looks so difficult. It's not. We can handle it, I think. Let me make sure. We're taking out an x squared. We're left with 35x to the 4th plus 12x squared. Now, again, we took out the x squared, but we still have to have a 1 there. That's why I say it's always in your best interest to draw these in, because you remember to fill all 3 holes. All right, x squared. Well, the easiest way to multiply to 35 is 1/2 times 70. Just kidding. Oh, God. Oh, God, I'm a comedian. 7x and 5x. Sound like I just came back from the dentist. Don't want to go there anytime soon. 7x and 5x. Easiest way to multiply to 1 is 1 times 1. Since this is positive and this is positive, signs have to be the same. In this case, they're both going to be positive. I'm actually finished. Done. That problem looked really hard, but it wasn't. Not bad. 4 terms. 4 terms on question 10. Since 10 has 4 terms, we're going to group them. Group these two. Group these two. I can take out an x squared. And I'm left with, again, wait a second, let me fill these holes. This one is tricky. I took out an x squared, I'm left with an x. I took out an x squared from x squared, I'm left with a 1. Copy over. Now, looking at these two, do they have anything in common? I'll give you a hint. They have a 1 in common. So I'm going to take out that 1. Which really means I'm just taking out almost nothing. The 1's always there. So I'm taking out a 1, which really means nothing changes. It's just still x plus 1. But that's what I want, because this is x plus 1. So my final answer is, and I know you guys are thinking, well, how can that be my final answer? Well, I factor out the GCF out of both these two terms, and I'm left with x squared plus 1. Well, can't you factor x squared plus 1? Not the sum of perfect squares, only the difference of perfect squares. So we move on. Anybody having fun? Raise your hand. Hi, I'm Mr. Krause. Having fun. Thank you. Thank you. Here we go. Moving on. We're going to group. We're going to group these two together. We're going to group these two together. Hopefully I did okay with this. Let's take out a 3x. Ooh, is that right? That makes me think I did this problem wrong. I can't possibly have done this problem wrong. Let's do it. Let's take out a 3x cubed. And I'm left with x minus... I did write this problem wrong. I must have written this problem wrong. We'll see. We'll check it out. We'll check it out. Maybe I'm not. Take out. I'm left with. Take out. So I'm left with x minus 2. No, I'm good. Over here, I'm gonna take out. Yeah, I did write this problem wrong. What in the world is wrong with me? All right. Let's just see here. This is not gonna work out right. We have to put an x here. So, and let's just forget about this problem. I miswrote that problem. We will scratch that one out and move on. I know that upsets some of you, because you're like, wow, I just gypped you out of one last math problem. And I know you're really upset about that. I'll make it up. We'll throw it at the end. Just kidding. Okay. Hopefully we'll get this one right. We're going to take out an x squared, and we're left with x plus 5. Minus, and out of these two I can take out a 9. I'm really taking out a negative 9, so we're going to get x plus 5 here. Now, some of you start to see things, and I know as I've worked with kids in the past, they start, wasn't that just x squared minus 9? And can I just simply write x plus 3, x minus 3? You certainly can. And I would encourage you to do that. I would absolutely encourage you to do that. It's perfect. If you don't see it right away, then say, okay, let me write it down. Oh, yeah, that's x squared minus 9. That's the difference of perfect squares. That's x plus 3, x minus 3. All right, I got it. Maybe you'll see it next time. Maybe you won't. Maybe you won't. Maybe you will. Maybe you won't. Moving on. All right. Again, this is going to be kind of a tricky one. Pay attention. I knew I did that one wrong when I had a 4 there, and my degrees weren't exactly right. Kind of messed up. No worries. All right. We're going to take out a 25x squared. And then I'm left with x minus 4, because 25 goes into 100. It's actually negative 100 4 times. Negative 4 times. I'm going to copy over the negative. Now, as I look at these two, the only thing that they have in common is 1. But what I'm really taking out here is a negative 1. You see it? This is really a negative 1. So this should be x minus 4. And if I redistribute this negative 1 here to negative 4, I get positive 4. And again, my parentheses match, which is what I want. Now, here's another opportunity for those of you that see it. Do you see 25x squared as a perfect square? And 1 as a perfect square? So once again, that's the difference of perfect squares. Now, for those of you who don't see it, let me write it out. X squared. Remember, we're factoring out the GCF from these two. So what's left over is 25x squared minus 1. Well, 25 is a perfect square. X squared is a perfect square. 1's a perfect square. We have subtraction. What's that? We have the difference of perfect squares. I'm going to write that up. X minus 4, 5x plus 1, 5x minus 1. Okay, moving on. Wow, this is like the math problems that never end. GCF, x. I'm going to put down a plus, I'm going to put down a minus, and I'm left with x squared plus x minus 12. All right, since the middle term, or excuse me, since the end term is negative, I know my signs, one of them has to be positive, one of them has to be negative, and they have to add up to 1. Well, that's easy. X plus 4, x minus 3, finished. I love problems like that. Can't you make them all like that, Mr. Gross? I could, but that'd be boring. So, we're going to group them. We've got 4 things. We're going to group them. By the way, if at any time you want, pause. Try the problem on your own. See how you're doing with it. See if you get it right. See if you don't get it right. See how much you've learned from me. Stop watching me like a monkey perform. Never mind. Keep going. I'll try not to act like a monkey anymore. I don't know where my thing is. Okay, here we're going to take out an x squared. I'm left with x minus 3. Copy over the negative. And I'm going to take out a 9. And I'm left with x minus 3. Did you see it? Because negative 3 times negative 3 is positive 27. And let's see here. Do you all see the next difference of perfect squares? Again, it's really x squared minus 9. Now, if you saw it, you could have written right here, x plus 3, x minus 3 immediately. If not, no worries, man. No worries. Just rewrite. You just have to use more lead. You'll be buying pencils faster. Show all your work. Show your teacher you know what you're doing. Maybe you get a little bonus points. All right. Difference of perfect squares. Again, the odd way of difference of perfect squares, but nonetheless, it's the difference of perfect squares. X squared plus 5. X squared minus 5. Again, these are called conjugates. They're exactly the same parentheses, just one's plus, one's minus. And those are not perfect squares, so I'm done. Here we go. X to the 4th. Get used to it. It's okay. X squared times x squared is x to the 4th, so we're okay. We'll put those at the beginning. This is plus. Signs have to be the same. They both have to be positive. Positive 1, positive 7. Again, we have the sum of things that aren't even perfect squares. Oh, that's a perfect square. But they're sums. I'm done. Did I just say I'm dumb? I'm not really dumb. I'm pretty smart, but I don't know where my pen went. Okay. The GCF here is kind of weird. You might just think it's x, but there's actually a bigger thing than just x. Both these are minuses. These add up to 9. That's divisible by 3. These add up to 9, that's divisible by 3. These add up to 6, that's divisible by 3. So 3 also goes into all of these. 3 goes into 15, so we end up with 5x to the 4th. 3 goes into 72, 24 times, so I'm left with 24x squared. And 3 goes into 108, 36 times. Not done. 2 sets of parentheses. The only way to multiply to 5x to the 4th is 5x squared times x squared. That's not necessarily true. I know there's a million other ways to do it. This is the easiest way. Since this is minus, the signs have to be different. And we have to somehow come out with negative 24. And if you think about it, you know, there's lots of different ways to multiply to 24. I'm not going through all of them. Or it's 36. You can do 3 times 12, 2 times 18. 4 times 9, 6 times 6, I'm going to try 6 and 6. 6, 6. Let's see. That's negative 30 on those and 6 on those. That's what I want. Minus and plus. I'm done. Guess and check. Again, this might be a difficult one to see. 16 actually goes into 256. So this leaves me with x to the 4th minus 16. 16 squared is 256. It's a perfect square. Believe it or not, this is actually the difference of perfect squares. But we had a GCF to begin with, so you have to take that out. X squared plus 4 and x squared minus 4. Now, those of you that saw it and was going to be x squared minus 4 there, could you have not put this and immediately said, okay, I know x squared minus 4 is going there. Can I just put x plus 2 and x minus 2 in? Sure. Why not? Save yourself a little time. All right, last problem, last difficult problem. Let's see. No GCF, so we're going to do 3x squared and x squared. Let's see, lots of ways to multiply to 24. I got 2 and 12, 3 and 8, 4 and 6. Let's see, I can't put a 3 here. I can't put a 3 here. I can't put a 6 here. No 3, no 6, no 12. But I can put those over here. If I put a 6 here and a 4 here, that would be 18 and 4. That ain't going to do it. If I put a 3 here and an 8 here. Oh, there it is. 3 here, 8 here. Because this is 9 and this is 8. And that's 1 if I subtract them. I want negative 1, so I'm going to minus here and a plus here. That's a tough one. That's a difficult factor right there. You guys can handle it, though. All right, now we're going to solve. When you're solving, notice we have an equal sign. I think we have 6 of these or 8 of these to do. I'm not sure. Let me look. We got 6, only 6. So when you're going to solve, you're going to end up with 2 answers, 3 answers, 4 answers, 5 answers. In this case, since it's a cube, let's see how many answers we can get. We're going to get more than 2. Maybe we'll get 1. Maybe some of them will be imaginary, non-real solutions. Got to be careful. We're going to check this out. We're going to take out an x squared, and I'm left with x plus 6. I'm going to guess negative 6 is one of my solutions. Copy over the negative. We got a 4. X plus 6 equals 0. Again, negative 4 times positive 6 is negative 24. So my first set of parentheses is x plus 6. I'm going to factor out the GCF out of these two, and I'm left with x squared minus 4. Now, yes, you could have immediately right there written x plus 2, x minus 2. Just be careful. Just be careful. Do it correctly. Correctly. You know what correctly means. But, yes, you have to continue to go. X squared. Oops. Excuse me. X, I like red, plus 2, x minus 2. Now later on I'm going to show you that you didn't actually have to continue the factoring. It didn't say factor completely, then solve. It just said solve. And I'll show you that you didn't really necessarily have to stop there, but it's probably in most of yours best interest to do so. Because otherwise you might screw things up. And I don't want you screwing things up. I like you guys. Even if I don't know who you are, I like you. It's a little creepy, isn't it? X equals negative 6. X equals negative 2. X equals positive 2. Now, I'm not showing you the math behind that. I assume you passed algebra, so you understand where those numbers come from. All right, this one looks kind of creepy. Let's take out a 4. Again, we're going to put our plus and our minus in so we don't move anything or miss anything. We're left with x to the 4th. We're left with 10x squared minus 11. Oh, my God, this factoring. X squared and x squared multiply to negative 11, add up to positive 10. Well, that's quite simple. Plus 11 minus 1. See the difference of perfect squares here, though? We're not finished. 4 x plus 1, x minus 1, x squared plus 11 equals 0. Now, we are going to end up with some strange things going on here. We're going to get a few non-real solutions. This one's going to give me x equals negative 1. This one's going to give me x equals positive 1. Now, this one, let's go through the solving of this one. I end up with x squared plus 11 equals 0. If I bring the 11 over, I get x squared equals negative 11. If I take the square root of both sides, I get x equals plus or minus. Now, the square root of a negative, by now, hopefully you know, is I, square roots of 11. I like that question. All right, that was lame. So you all know that whenever we're going to solve polynomials, we must set them equal to 0. I don't know why I just wrote down a plus sign. When we bring that 10 over, it's going to be minus 10x, and it has to go in the middle, plus 9 equals 0. So all I did was take this, bring it over, change the sign, put it in the middle. All right, we're going to x squared. Now this is going to be some crazy cool stuff going on here. X squared and x squared. There are actually 4 answers to this, 4 real solutions to this one. Minus 9, minus 1. Now, I'm going to show you on this one. I can factor this to x plus 3, x minus 3. I can factor this one to x plus 1, x minus 1. And I would get my solutions 1, negative 1, 3, negative 3. The other thing I can do is I could say, okay, I know that x squared is equal to 9. I need this to be equal to 9 in order for it to be 0. So then I could say, if I take the square root of both sides, take the square root. When you take the square root, you have to remember to put a plus or minus. I could say plus or minus 3 here. And again, x squared equals 1. Take the square root of both sides, I get x equals plus or minus 1. There's your 4 answers. 3 left, and we're done with this one, kids. First things first, we are going to bring the 4x cubed over and put it in the right place. I'm a little nervous, but I think we're okay. 2x to the 5th minus 14x cubed plus 24x equals 0. Take out a 2x. I think this is going to turn out to be okay. X to the 4th minus 7x squared plus 12x. No, we took the x out. I'm not taking out the eraser, too much work. Ah, this one's easy. 2x. X squared minus 3. X squared minus 4. Now again, I could take that x squared minus 4 and write it to x plus 2, x minus 2, and get 2 answers. Or I could just realize that's going to generate 2 answers. Now this one's got some strange answers. I got 5 answers, I think, coming. I get the answer x equals 0. This one is x squared equals positive 3, or x equals plus or minus the square root of 3. This one, x squared equals positive 4, or x equals plus or minus 2. Now notice this one gave me an answer of 0. When this problem here, did not give me an answer. There's no x out here. There's no way to make this single 4 into a 0. So that doesn't give us or generate a solution. Whereas up here, this was a 2x. And if I make x 0, 2 times 0 is 0. So a 0 is, in fact, a solution of this one. All right, we're almost done. This one looks crazy. Crazy. Awesome. Let's take out an x to the 4th. That's making me nervous. Leaves me x squared minus 4 minus, take out a 9, I'm left with x squared minus, oh, this is sweet. This is a super cool question. I took out the x, so what I've left with is x to the 4th minus 9 here, factoring, oh, I should have put the x squared minus 4 first. That should have been first, but that's okay. You guys see. Wow. I'm going to keep going on this one. There's a lot of factoring left to do on this one. I'm going to leave this one. No, not a lot. This one's x squared plus 3, x squared minus 3. This one is x plus 2, x minus 2. Crazy solutions on this one. On this one, I'm going to end up with x squared equals negative 3. Remember, when you take the square root of negative, you're going to end up with an I, or imaginary numbers. So this gives you your non-real solutions right here. We're going to get x equals plus or minus I square roots of 3. This one's going to give me x squared equals 3, so that just gives me x equals plus or minus radical 3. And these ones over here ought to be so easy. X equals negative 2 and x equals positive 2. So I end up with 4 real solutions. Yes, the square root of 3 is a real solution. It's just irrational. That's no problem. And 2 imaginary solutions. Oh, man, was that a cool question. Last question. What in the world am I going to do with this problem? Well, first of all, I know that if I'm going to solve it, I probably want to set it equal to 0. So I'm going to go 48x to the 5th. Minus 27x cubed. I want to make sure that my largest degree has always got a positive leading coefficient. It makes life so much simpler. Let's see, what's the largest number that I can take out? I think I can take out, the largest thing I can take out is actually a 3. And I'm also going to take out an x cubed. 3 goes into 48 16 times. So we're going to do 16x squared minus 9. That's the difference of perfect squares. So I end up with 3x cubed, 4x plus 3, and 4x minus 3 equals 0. That gives me 3 solutions, 3 real solutions. This one's going to give me x equals 0. Clearly, if I plug a 0 in for x, this whole entire thing turns out to be 0. I'll walk you through this one. 4x plus 3 equals 0. I'm going to subtract 3, bring it over to the other side. I get 4x equals negative 3, or x equals negative 3/4. I will not walk you through the other one. If this is negative 3/4, clearly this one's going to be positive 3/4. Now, that's it. 26 questions. I hope you had as much fun as I did. No? Still watching? You still with me? You're waiting for me to do something stupid. You want me to throw another problem up? Why are you still watching then? It's like those credits that keep rolling and you keep watching. Why you keep watching? I don't know why you're still watching. You can't stop watching, can you? It's the bald head. I know. All right. Peace out. Signing off. Hasta la vista. Hasta luego. Tschüss.